Good morning, good afternoon, wherever you are. Welcome to another Mobile Mapping Essentials webinar focusing on our mobile mapping solutions. This time we are really excited to actually show you some workflows or possible workflows combining a number of different of our cool technologies. So the topic for today is doing mobile mapping data validation using Trimble SiteVision augmented reality. Our SiteVision augmented reality tool, as well as Trimble TerraFlex. And you'll see that a couple of other things come here together as well. And today the webinar will be presented by Dennis Belgrado, based out of our Dubai office. I'll hand it over to you, Dennis.
Well, thank you, Ronald. Thanks again. So yes, hello, good morning, good afternoon, good evening. Maybe not good evening, but yes, so wherever you are. As Ronald already introduced me, so my name is Dennis Belgrado. I'm the technical sales engineer based out of Trimble Dubai office, and I'm a member of the advanced solution team for the EMEA region headed by Ronald. Right. So I think just a couple of housekeeping here. So at any given time, if you have question, just type your questions in the question box, and we will answer that later on during the Q&A portion. And that's it. So let's go ahead and my mouse is not working. Right. Let's go ahead to the overview or the agenda. So just a quick overview here. We will be looking at the MX9 data extraction in TBC and TMX, and also we'll look into the write or export of this data into ArcMap, ArcGIS, followed by the SiteVision AR technology. So we will quickly look into how the data, how we check the data on site for any, let's say, missing features or checking the validity of this extracted data in 3D. And also because the SiteVision has a basic measurement function also via AR or GNSS and ADM, we will quickly look into that as well. And lastly, we will look at the TerraFlex data collection and update using the ArcGIS plugins. Again, as Ronald has already mentioned, so we will be touching on some of these softwares that are going to be for this workflow. So one of that is the Trimble Business Center, TBC, Trimble MX Asset Modeler Pro, SiteVision Visualization Manager, a little bit of the SketchUp, Trimble Connect, and the Trimble TerraFlex. Right. So here's a sample MX9 data in Trimble Business Center, the TBC. So it's a sample that we collected right outside our office building here in Dubai. So here you can see a picture that speaks 1,000 words, so they say, right? But then again, this is not a picture. This is in fact better than a picture because it's a point cloud with millions upon millions of points with precise 3D coordinates, right? So of course, because this is a point cloud, you can extract accurately all these features that you want or need for your project. So for instance, here I'm using the TBC Card module, and I extracted different types of features. As you can see on the map, I've extracted the building outlines, the center lines, curb lines, lamppost, signpost, trees, and so on. Just a note, by the way, that a new and improved CAD command line in TBC version 5.3 has been released this week. Really powerful function. So I encourage you all to have a look and check that out. So it's an excellent tool for quick and precise data extraction. Right. So speaking of precise data extraction, so just quickly showing you here how we can utilize the TBC CAD module to extract precisely, the point from the point cloud. So here we're using, or I'm using what we call point cloud smart picking features, right? For creating line works or just simply creating a point. So sure, you can use a point and click, so you can just click anywhere, and that will give you also an accurate result, But smart picking is smarter, right? So in this example, smart picking has 4 types of smart picking. there's the default where you select and click wherever your mouse pointer is, and that gives you that coordinates. And you also have the face of the curve, the gutter, and the road marks. Right? So the face of curve, the gutter, and road mark, basically the TBC uses its artificial intelligence to define or to identify that point. So as you can see here on the screen, I'm using the gutter, and I just roughly click on the point cloud, and then it gives me this screen to validate it, and I can do I can refine it if needed as well, right? So another example here is the road mark. So again, if I need this road mark, I just simply click on the roughly on the road mark object, and then it gives me again this window to to refine the selection, right? If needed, of course. Um, Again, using the TBC GIS module here, extracting trees from TBC is really powerful and really accurate, right? So not only that you get the XYZ values of this, being the XYZ values is right in the center of the trunk, and also the Z value is clamped on the ground. You also get automatically the attributes, like for instance the trunk, the size of the trunk, the size of the spread or crown of the tree, and the height, right? Um, So you can do that either by manually, meaning one by one, or automatically, and the TBC AI will find all of the trees from the point cloud. So as you can see here, I'm only using as an example two of them, but yeah, so TBC has this powerful AI that can search the point cloud for all of the trees in the data set. Um, just quickly moving on here, lamppost, right? Lamppost and signs. So similarly, like the trees, the TBC will automatically extract attributes such as the pole diameter and pole heights, and they are automatically detected. And again, the X and Y values are also placed in the middle of the pole itself, right? And then the Z value is also clamped on the ground. And again, very, very good news for TBC version 5.3, just released this week again, that earlier on, we can only do manual extraction like one by one. But now, just like the tree extraction, you can now extract automatically, and the TBC will find all the lampposts or all the signs from the point cloud. And that's really a powerful stuff. Um, so here, so we have now extracted all that data, right? So if you want to bring all those data into the third-party software, such as the ArcGIS, ArcMap, as you can see on the screen, you can use this module, TBC GIS module, and it's a very powerful tool that, because it can read and write directly into the file geodatabase. So you don't need to do import and export of shapefile. Just read and write directly. And um, Marco Bello, my colleague in the Advanced Solution team, he's done a really good job about this last week, and he has a very detailed workflow on how this function works. So I encourage you all to check the previous mobile mapping webinar series for this subject. So that's the MX9 data in TBC. So let's quickly look at how the same data is processed or viewed in the Trimble MX asset modeler. So here, for instance, we're looking at the 2D view, and then the panoramic view, and then the 3D point cloud view here on the side, and then all the tools needed for extracting the features that we need. And TMX is really powerful for semi-automatic or fully automatic functions, right? So for instance, here on this example, I'm using the multiple reads tool to extract a curve line, and also offset the yellow line, the center line, more lines, and other curve lines. And as you can see from here, because of the density of the MX9 data, I mean, I only have 1 kilometer of data sets here, but probably if I have longer than that, it would have extracted all of them without break as well. So as you can see here, it's done around 900 or almost a kilometer lines, right? So this is a very powerful function of the TMX. Um, Again, if you just want to, let's say, extract the yellow line, so by just 2 clicks, then here it is, the red line, sorry, the yellow line is also extracted very, very quickly. Another one, we used to draw these pedestrian boxes manually. So with this function, you don't need to draw them manually. You just click the beginning and the end, and then you get the yellow, or sorry, the pedestrian box extracted, as you can see here also in the 2D map view. So once again, all those data had been extracted, so you get them into ArcGIS. If you're using, I keep using ArcGIS because here in this part of the world, so ArcGIS very popular 3D software. So here you get the data exported from TMX. You export that into shapefile. So in TBC, you read and write directly into file database. In TMX, you export that into shapefile. So of course, you can also export in different formats such as DXF, GPX, KML, KMZ. And again, so those were just a few examples on how to extract features manually or automatically using TMX or TBC. And then there are a lot more other functions or extraction ways that you can do, but I've only outlined what is needed on this workflow. So here's the same data view of the extracted data in the ArcGIS and ArcMap. And now we can bring this data to the site and use the SiteVision AR to verify and validate the data integrity or see if we've done a good job. I mean, looking at the data in 2D can be all great in that, but when you go to the site, it could be different thing, right? So that's human errors, right? So let's quickly look at the SiteVision augmented reality technology. So here on this picture, right? So this picture sums up everything. So integrating the power and the accuracy of Catalyst GNSS antenna, the EDM, electronic distance meter for remote measurement, and the AR technology capability of the today's high-end smartphones. So basically, utilizing these technologies that we already know in use every day. So it creates a new tools and very exciting tools for us, geospatial professional, to help us, be more productive and be more effective in our day-to-day work. This is just a breakdown of that. So on the left-hand side, you see the actual unit, the integrated hardware, and you see, I don't know if you can see my mouse, so that small hole there is the actual electronic distance meter. And of course, you have the Catalyst antenna and then the SiteVision app, and and the bring your own device, mobile phone. So for a smartphone, it requires a minimum Android version 9 operating system. So and also there's a live data or database that we're updating in the SiteVision website, but I've captured some of them here. The Trimble tested mobile phone like the Samsung S10 or S9 Plus, Note 10, Note 8, and so forth, and other compatible smartphone as well, as you can see on the right-hand side. So with this, so now we have a very high accuracy geospatial visualization tools, right? As you can see on the screen. So a lot of data, a lot of information laid, and if the data is also geo-referenced, they will magically appear exactly where they should be on the map, right? But for that, of course, we need to do the initialization. So if you initialize properly, or if the initialization and the correction is done properly, then of course, all these things will appear on the map where it should be. So here's the quick view of the SiteVision initialization. So basically here as an example, I'm using my SiteVision connected to my Trimble R9 GNSS receiver, R9S GNSS receiver via Ntrip, receiving RTCM correction to achieve centimeter level of accuracy. As you can see on the top left corner, the green icon there shows 9 satellites and 2 centimeter accuracy. So SiteVision can be really, really accurate also. And once the accuracy is done, then the next thing that we want to do is to walk around 10 meters ahead, and the orientation will be fixed, right? so once the orientation is fixed, now the SiteVision is ready for data verification and validation in 3D. So let me just quickly play this quick video here. So as you can see here, the data which is supposed to be the no entry sign, right? So we saw it from the earlier 2D map in ArcGIS and in TBC. I deliberately made this mistake just to show the point. So as you can see here, the no entry signs, the attribute should be no entry sign, but it was entered incorrectly, human error. So instead, it was entered as a straight ahead value. So the SiteVision interpreted the attribute and displayed the 3D model and place it right next to the no entry sign. So with this, you can quickly see in 3D, if there's a mistake. And again, also, if you look at the line at the bottom, so the curve line, I did not actually again, deliberately, I made a small error extracting this. So as you can see, the curve line is not captured correctly also. So again, you can really use SiteVision in the field to validate the data integrity, right? And then if you want to see some more data, of course, you can just walk around, or maybe you can drive and then look at all of your data set, see if there's any more operators or human errors. So another example is the to see what we missed in the field, right? It's good to see what we already have, but it's also good to see what we actually missed. So here in this example, you can see the manholes and some lamppost has no data, right? And there could be many reasons for this. So for instance, maybe during the MX9 data collection, there were cars parked beside the road, so blocking the view of the MX9. Therefore, the MX9 were not able to capture these things. So again, you can quickly see in 3D what you have and also what you missed. And with that, though, and with that, we can also use the SiteVision to perform a basic data collection. So here, for example, I'm using the EDM, and here you can remotely capture the manhole and then type the manhole name and also the attributes. Right. So you saw that car passing like crazy there, right? So that's another good reason of using the EDM, and so that you don't get wet and you don't get splashed with the water like that. Yeah, so that's another example. So EDM used for remote measurement of points. And also, because the SiteVision has a very accurate catalyst antenna receiver, also you can use the GNSS to capture position as well. And when you select the GNSS, then you will be able to enter the pole height here, to enter the pole height, so that you'd have a good vertical reading. Okay. Now, let's just quickly look into what you actually get when using the SiteVision in terms of data. So the SiteVision, when you do the measurement, it stores a CSV file in the mobile phone. And when you get and open that CSV file, you see a lot of information here. So you have the date, of course, the time, the code, and also the measuring mode. So whether you use the GNSS, if you use the EDM or AR, And all of this latitude, longitude, or northing elevation, and all those, and also the accuracy for quality purposes. So there's a lot of information that you can get out of the site vision data. Right. So now we have all of this data extracted from the TMX or from the TBC, right? So now let's say 6 months down the line, or maybe a year down the line, for sure there's a lot of things happen in between, right? So let's say now you want to send your GIS maintenance guy to check the status of these assets, right? So for this example, I'm using ArcMap, ArcGIS, and here you can use the plugins to quickly log into to TerraFlex and create a project. And then from here, you can also create a task. And basically, you just select the features that you want, and then you can send that feature to the team or to the person and assign that to the person close to that area. And here you can see also the TerraFlex with that information sent and assigned to that particular person. And again, as I've said earlier, there's a mobile mapping webinar last week that has this in full detail. So again, I urge you to check that out. So the reason why we're using, or why we're saying use TerraFlex for data collection and update, and here as you can see, by the way, that's me. Um, so so here as you can see that with the TerraFlex you can get centimeter level of accuracy. It's the same as the site vision, right? So in the open area or open space like this with with less multipath or Genesis signal disturbance, so you can really get this much of accuracy. So otherwise, if you're working in a very dense environment, a lot of signal disturbance, a lot of multipath and stuff like that, we always recommend you to use the Trimble R series Genesis receivers, which the TerraFlex also supports. Yeah, so with using that, then you would get better result in that type of environment. Again, in the open space, open area, you can use the TerraFlex for update. Right. So another software that we need to look at, and it plays an important role on how we can get the MX9 data into the field into the on-site 3D validation, right? So so here is the Trimble Connect. So what is Trimble Connect, you ask? So let's think of it as a Google Drive on steroid. Anyway, so kidding aside, so it's where we store the data for the Trimble SiteVision and TerraFlex to use in the field. So it has a lot of other functions, not only for geospatial purposes, because it's also used in construction, it's also used for BIM applications, so on and so forth. And the best thing of this is that the user interface is so simple. I mean, all of us are using web, all of us are using internet. So it's just a matter of dragging and dropping the data into it. So you create your folder, you create your project, and then remember that zip file, remember that TMX shape files we extracted. You just have to zip them and drag and drop into the project folder. And then once the data is ready to be used in SiteVision, you will see this thumbnail showing the data. In TBC, we have what we call AR exporter, and with this, you can export all those data that we have, not only the points in line works. You can also export the the contour lines, um, the 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 surface information, in addition to the points in line works, into Trimble Connect directly from within the Trimble Business Center. So here's the example of that. Looking at the here's the example of the Trimble shapefile into the view in Trimble Connect, right? So this one here is the view in Trimble Connect showing the data exported from TBC using the AR exporter. And you can see from here, it has more tools that you can use. You can find certain object. You can look at the properties. You can see it in 3D and so on and so forth. So there are more functions available here. Again, just a quick view in SiteVision when you export the data in AR exporter with additional information like the surface, whereby in the field you can use the SiteVision to measure the cut in field values from that surface, also the grade information as well. So it's a very powerful tools to have in the field. Now, the last piece of the puzzle here is the SiteVision visualization manager, right? So basically, this allows us to create rule sets that the Trimble SiteVision will use to interpret the shapefile or the data in order to display the 3D object or the 3D model in the field. So for those of you who are already using Trimble Business Center already, TBC, think of it as the feature definition manager for creating feature libraries. So you create the line, you create the points, and you want that to be displayed in the particular manner in TBC. So this is the same way to that. So basically, this defines the object, and and you can use different types or different information from the shape files. For instance, you can use the feature class name and display specific 3D model based on that. Or maybe like an example that I used earlier, I used the attribute values. So I look at the attributes, let's say sign type, and then the sign type equals, let's say, the value, and then it displays particular 3D object, right? Or maybe there are some special cases or special rules particular to that feature that you can also use. So again, so once the rule set is created, so you can now just drag and drop that file into the Trimble Connect project folder, ready for the SiteVision to use. And if you're interested, again, there's a very detailed step-by-step a webinar that has been done on this particular subject by Miko Ramos. If you want, or just go to the SiteVision YouTube channel, and I think it should be there. Anyway, so that's the SiteVision visualization manager, and the 3D model, you can be really creative here. You can display the feature in 3D, entirely up to you. So you can use the Trimble SketchUp, and you can draw the model from scratch, or you can download from Trimble SketchUp 3D warehouse and use that in the project. One thing to note though is you have to make sure to align the model's origin or XYZ origin, so that the SiteVision will use this as the insertion point in the field. So if there's an offset, then obviously you will not see this properly in the field, right? Okay, so that's that. So the SiteVision visualization manager comes preloaded with all of this information that you can see now on the screen. So it's ready to use. But again, if you want to add some more, then you can add some more using the SketchUp you want to draw. I think that's the last part. And here we have the online resources. I already mentioned about this. So all of those about site vision, all of that site vision visualization, you can go to this YouTube channel and you will find all of those information from there. Site vision visualization manager, you can download it for free. You go to the support page of the site vision website and you'll find it there. And of course, you can also go to the Trimble SketchUp, and I think there's a web version that you can draw your own model. There are more webinars like this that you can go to. Trimble webinars, geospatial.trimble.com/webinars home. There's a lot of webinars there. You can also view all of those previous webinars from that site, and of course you can register to the upcoming webinars from there as well. Specifically to another mobile mapping essential webinar next week will be conducted by Ray Wu. That would be on May 7th, 8 a.m. to 9 MDT time. So, she will be covering the MX9 feature extraction in TBC. And if you want some more information, um, anything about what we've covered or anything about mobile mapping in general, so please send an email to mobile-mapping@geospatial.trimble.com. I think that's it, and we can now open for the Q&A. Ronald?
Yeah. We during your session we got a number of different questions in. The first one here is whether it's possible in SiteVision to show the point cloud coming from the MX9 directly in there, so showing the actual point cloud.
I think no. I mean, point cloud is a very resource-hungry file, right? So, and you're using a tiny mobile device, so there's always a limitation of what a tiny device can do. So, yes, I guess you can just cut some small part of that point cloud, but no. For now, the straight answer is no, not yet,
Oh.
or no.
Yeah. Also, a couple of questions on SiteVision and whether you could use a receiver like an R10 or an R12, for instance, with SiteVision instead of Catalyst.
No, because the sight vision bracket is actually molded, or the antenna, the catalyst antenna is molded on the top of the bracket. And the sight vision is designed for handheld type of application. And I guess different types of receivers, such as the R10 or R12 or R8 series, they will be a little bit heavy for handheld type of application. So again, the quick answer is no.
No, exactly. And on that as well, there were some questions on whether you, for instance, need your own base station or not, and as well as what kind of accuracy do you get if so you don't need your own base station, right? But also what accuracy can you achieve with the corrections that we are supplying?
Right. Okay. So that's a very good question. So, of course, so the sight vision can receive correction not only from the satellite or from IP, but you can also, as the example that I have shown earlier, you can also use your own base station. So again, as the example that I have shown earlier, I use Trimble R9S Genesis receiver, and I was broadcasting RTCM version 3 from there, and I was receiving that correction using 3G. So with that setup, I was able to get as much as 2 centimeter accuracy, right? And because that's a single base type of a scenario, my accuracy will be limited to probably around 20 kilometers distance to that base station. So on the receiving the correction from the satellite or from the RTX, then there's a couple of scenarios there. So depending on where you are, there are places, let's say Europe or America or Australia or New Zealand, where there are more base station, or the base station for the RTX are more dense, and you can basically get down to as much as a centimeter level of accuracy. Yesterday we had a session about TerraFlex, and someone commented that in the US, the coverage and the accuracy for RTX is really improved now. Now, in some places, for instance, in the Middle East, I'm not sure exactly in the Asia Pacific or Asia how much accuracy they would get, but in the Middle East, for instance, because the density of the RTX ground-based station here is not as dense compared to Europe and America and New Zealand, we can only get, in my own testing, I was able to get around 20 centimeter accuracy. Most of the time around 20 to 30 centimeter accuracy in the Middle East.
Oh.
Yep.
Okay. Thank you. Yeah. Another question related to sight vision. When you were showing initially, right, where you were saying that you needed to walk about 10 meters straight. So the question was, the direction is based on built-in compass/IMU, or by walking between two known points to calibrate the 3D view. The 3D
So, yeah.
view.
So yeah. So there I was showing like 10 meters. By default, it sets there. It was set there as 10 meters. So you can also increase the distance to let's say longer than 10 meters, and that should give you more accurate initialization of the view, right? So it's based on the AR capability of the device. So it's not based on the IMU. It's not based on 2 points. It's based on the compass and the AR of the device.
Another one is on what type of data we can view on Trimble SiteVision.
So the example that I used, we're using, or I used shape files, and so that was from the TMX. And if you export from TBC, then that creates what we call the TRB files, and I think other datas are also supported. I don't have in the top of my head all those datas, but I know that there are more other data sets that are supported. So we can send you the link to the Trimble SiteVision, where we have all of this detailed information on what data is supported, what type of scenario this type of data can be used. So there's a lot of that. So yeah, so not only shapefile, not only TRB files from TBC, there are more other files that you can use in TRW. So we will send you the details or the link to the Trimble SiteVision website.
IFT, DWG, for instance, right?
Yeah.
It might also be worth going to the geospatial.trimble.com website and look at some of the earlier webinars we have run. There are a couple of site vision specific webinars there available as well that you can still watch. Another one also related to site vision here was whether we can use iOS devices or Apple devices.
No, because the site vision uses the Google AR Core technology. So I think that's only available in Google Android OS. So no, so for now, no. So only Android device is supported. So not iOS.
Yeah, thanks. Then and also an interesting and good question, I think, is you showed TBC and as well as Trimble MX. So the question is, TMX, TBC, or both? What to use?
What to use for data extraction?
Yeah. Yes. Sorry.
Right. Okay. Well, the couple of example that I have shown there is basically the TMX is really powerful software for quick automatic data extraction. For instance, as you've seen there, the curb lines, and the offset to all those road lines and the yellow lines and center lines and stuff like that, or maybe the pedestrian crossing, right? So it's really, really good for quick data extraction, automated data extraction. Again, you can also extract poles and signs very quickly using TMX. TBC, on the other hand, as I said earlier, there are some new functionalities now that also introduced in version 5.3. It's a really powerful software if you want to extract the feature in a more of a civil engineering type kind of accuracy scenario. So let's say you want to exactly measure the corner of the object, or maybe the corner of that curb line, or corner of that road mark. So yeah, so precise extraction of information, I would say TBC.
All right. Thanks, Dennis. I think we're coming to an end here. Thanks again for your presentation. I think it was a really
Thanks a lot.
one with all the different technologies coming there together.
So let me just quickly put the mobile mapping email address here. So again, if there are more questions, so just send your details here, and we will be happy to come back to you and answer any of them.
Exactly.
Thank you.
In the chat window, we also copied the link to the registration for that webinar next week Thursday, on MX9 feature extraction in TBC that you mentioned before. With that, thanks everyone for attending, for joining this webinar. Thanks, Dennis, for presenting, and I wish you a very nice day. Thank you very much.
Thank you all. Hope to see you again.